In previous sessions, we learned the geometric methods of adding vectors. In this session, we're going to learn the algebraic method of adding vectors by either applying the component method or by applying the laws of sines and cosines. However, the component methods may require the knowledge of breaking up vectors into their components. Finding the resultant of two head-to-tail vectors A and B can be done geometrically by drawing a line from the tail of the first vector up to the head of the second vector, where the magnitude of the resultants can be obtained by using a ruler and measuring the length of this vector. However, its direction can be also estimated by using a protractor to find the angle of r with respect to the x-axis. Now, how can we find the resultant algebraically by using the component method? Next, we're going to set up solving strategy to do that. The first step in our solving strategy begins by looking carefully into the problem and sorting out the known variables and the unknowns. Let's assume here that the magnitude of the vector A and its corresponding angle and the magnitude of the vector B and its corresponding angle are given. The second step in our strategy is to break up each vector into its corresponding components. Here, the vector A can be broken into x component, ax equals a cosine theta A, and to its y component, ay equals a sine theta A, and similarly, vector B is broken into its x component, b cosine theta B, and its y component, b sine theta B. Next, we'll add up the components along the x-axis in order to get the magnitude of the x component. Similarly, the y component of the resultant is obtained by adding up the y components of the vectors, and here we are. Now, next, we can apply Pythagorean theorem to find the magnitude of the resultant vector, and the corresponding angle can be obtained by tan inverse of ry divided by rx. In such case, we can substitute all the values and evaluate the answer, and then we can compare the answer with the earlier estimate made by the geometrical method. Here it's interesting to mention that the head-to-tail vectors can be replaced by tail-to-tail vectors if we move the vector B from here, right here to the origin, so such that we'll get a tail-to-tail vectors, and the procedure of adding vectors will follow the same way as we have done just right now. To find the resultant for the head-to-tail vectors A and B shown here, assume that the magnitude of A and the magnitude of B are given, and their corresponding angles are also given. Now, to do that geometrically, simply we draw a line from the tail of the first vector up to the head of the second vector. So we expect the resultant r to be in the fourth quadrant. So how can we do this addition of vectors algebraically? Well, first step, this vector B can be moved to the origin like that to make the algebraic method of adding vectors easier. And now break up the vector A by projecting a line along the x-axis and obtaining the x component of the vector A, and similarly finding the component AY, and then also applying the trigonometric relation to get the x component and the y component. Similarly, for the vector B, the angle theta is given with respect to the positive x-axis. So if we plot the x component by projecting a line from the head of the vector B along the x-axis, then bx can be obtained, and then another line projecting it on the y-axis, the y component of B. And here we have the x component of the vector B and the y component of the vector B as well. Next, add all the x components along the x-axis and also the y component along the y-axis. Here it's obvious from the diagram that by is larger than ay. So it's expected that the y component of the vector is going to be in the negative direction along the y-axis. So the x component is towards the east, while the y component is towards south. Now, to find the resultant, there are two ways to write the resultant. Either write the vector in terms of I hat and j hat, like this, by adding the x component of from the equations. We'll get the same as what we have done on the diagram. So Rx and Ry in this notation and this representation of the vector. Again, if you want to find the magnitude of the vector, as long as the Rx and Ry are obtained, so we can find the magnitude of the resultant by using the Pythagorean theorem. And the angle theta with respect to the positive x-axis can also be determined using tan inverse of Ry over Rx.